Today's video, here is a nice problem. Is coming from the Russian Mathematics Olympiad edition 1989. Here is the following setup. Find all x and y as integer numbers. Satisfy this following equation. We have x squared equals y squared plus 2 times y plus 13. Okay. In fact, the most useful and common method to solve this equation is a factorization. Okay. Let's to see something beside the factorization. Okay. So I'm going to do this one in two different way. Okay. Let's take a look at this one to see what's given us. Okay. So by the way of contradiction, let's put x for all x belongs to this interval minus infinity minus number 4, not including minus number 4, okay, is union to 4, not included 4, up to infinity. Okay. So at this moment I'm going to divide this one into two cases. The first case, case number 1, for all x is strictly inferior than minus number 4. Okay. So I'm going to zoom this one in by including minus 5. I get here this one equivalent. I get here x is inferior equal to minus 5. Okay. So let's square this one. Let's square both sides of this one. So I get here x squared. I'm going to flip this inequality because we have, when we square something is negative, the inequality is going to be flipped. Okay. So I get here x squared is super equal to 25. Let's replace x squared with this function. Let's put this one as a f of y function, which is equals y squared plus 2 times y plus number 13, which equals x squared is super equal to 25. Okay. So this one is telling us f of y is super equal to 25. So what this value is representing at this moment? This means f of y is accepting 25 as a minimum value. Okay. So the minimum value of f of y is 25 on this interval. Okay. So this is for all y as a real number. Okay. So let's check the other side. Let's check the second case. Case number 2. So I get by choosing the other side of interval. So I get here for all x is strictly superior than number 4. This one implies x is equivalent, x is super equal to 5 because I'm going to include number 5 here. Okay. So I'm going to do the same thing, squaring both sides. I get x squared is super equal to 25, replacing x squared with this function as well. So I get here f of y, which equals x squared equals y squared plus 2 times y plus number 13, which is super equal to 25. So I get the same thing here. F of y is always super equal to 25. Okay. So both intervals indicate this function, which is f of y, is accepting number 25 as a minimum value. Okay. Let's put this one in the graph. Let's save this one for later and work on this function to see what's the status of this function. Okay. So this function f of y, which equals y squared plus 2y plus number 13, for all y as a real number, I'm going to make the first derivative function of this one, which is f of y, f prime of y, which equals 2y plus number 2 equals 0. I'm going to put this one in the variation table. So I get here, I'm taking number 2 as a common factor. I get here y plus number 1 equals 0. This one is starting as y equals minus number 1. Let's put this one in the variation table. I get here minus infinity plus infinity. Okay. Let's put this minus number 1 here. We get this one is negative here. You get positive here. So this function is decreasing and increasing on this interval, decreasing on this interval. So replacing this one, when you have this one is going towards minus infinity, you get plus infinity. Minus 1, replacing it with minus 1 here, you get 1. Minus 2, which is minus 1, plus 13, which is 14, minus 2, which is 12. Okay, so we get the minimum value is 12 here. The limit as y is going towards infinity equals infinity here. Okay, let's put this one in the graph. We have minus 1 here, minus 1. So let's put, for example, let's put this one as a 12 at the input minus 1. This function is accepting 12 as a minimum value. So this function is going, the function is coming from the above. This function is going like this, then is going like this. This is a critical point for this function. So the minimum of this function is 12. Okay, which means that f of y is superior to 12. But we already found f of y is superior to 25 here, which is a contradiction. This one is a contradict. This one is contradicted minimality of this function. Okay, which means x is not belongs to this interval, which means x is not from this interval, which means x is between this interval minus number 4 and 4. Okay, because we have studied this one on this interval and we found a contradiction, which means x is not belongs to this interval, but x is belongs to this interval, which is a solution for this equation, which means x, I'm going to take the following values. X is belongs to this set: minus number 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4, including number 4 here. Okay, if you check all these values, you will find x is not, this is not okay, number 2 is not okay, number 1 is not okay, 0 is not okay, minus 1 is not okay, minus 2 is not okay, minus 3 is not okay, but x minus number 4 and x equals 4 is okay. Okay, because when you replace these values here, they give us a perfect square. This is the reason why this one is okay, this one is okay. Okay, because since we are working on the integer numbers, so the only values which give us the perfect square for this one, which is this one. Let's replace this one into x squared to find y. Okay, previously we checked the status of this equation and came up with this final values of x. Now we are ready to find y. Let's take these values of x and insert them into this equation to find y. Okay, so x equals minus 4. Taking this value and replace it here, becomes 16 equals y squared plus 2y plus number 13. I get y squared plus 2y is giving us minus 3 equals 0. Okay, let's split this 2y into two terms. So I get here y squared plus 3y minus y minus 3. Okay, let's take this 3y and minus 3 as a common factor and y squared minus y as a common factor. So I get here y factor y minus number 1, and also taking this plus 3 make it y minus number 1 equals 0. So here is a common factor y minus 1, so this one equivalent y minus 1 factor y plus number 3 equals 0, which means y equals number 1 and y equals minus 3. Okay, I found two values of y. Let's summarize this one and put all the solution on this side. So for x, I get x. So the value of x equals minus 4 or x equals 4, you will have the same solution, because when you square minus 4 is always get 16. 4 squared is giving us 16. Okay, which means we don't have to go through the x equals 4. X equals minus 4 is enough to find y solutions. Okay, so for x equals 4, is giving us y equals 1 first. Then x equals minus 4 is giving us the same y equals 1. And also x equals 4 is giving us another solution, y equals minus 3. And also x equals minus 4 is giving us y equals minus 3. Okay? This is the 4 solutions that we have. Let's move on forward and work on the second method. So also, by the way of contradiction, suppose y is strictly superior than number 1. Okay? Let's set y equals number 1 plus k. What is a k? Is a some natural number. Okay? So k is a natural number, which means k must be superior to 1. Okay? You're replacing, if you're taking k equals 1 as a minimum value, you get number 2 here, which is, okay, y is superior to number 2 here. Okay? This one equivalent to this one. Okay? Now let's take this value of y and replace it into this equation. I have x squared equals 1 plus k square plus 2 times 1 plus k plus number 13. Let's expand this one out. I get k squared here plus 2 times k plus number 1 plus 2k plus number 2 plus number 13. So I get here x squared, which equals k squared. I get 2k plus 2k, which is 4k. 1 plus 2, which is 3. 3 plus 13, which is 16. Let's transfer this one into inequality. So we get this one is bigger than k plus 2 quadratic square. Because if we distribute this one, you get k squared plus 4k, which is good to go for these two terms, plus 4 here, but we have plus 16, which exactly this one is strictly inferior than this one. Let's check other side of inequality. This one is strictly inferior than k squared plus 6k plus 9, which equals k plus number 3 quadratic square. But what's the condition of k in order to have this inequality holds? Okay? Let's make the comparison between this side and this side in order to decide which condition of k in order to make this inequality holds. Okay? Let's make the difference of this one and this one. I get here. Let's put it in this on the side. Let's put it here. We get k squared plus 4k plus 16 is strictly inferior than k squared plus 6k plus 9. You get k squared with this k squared cancelled out, which is 7. 7 is strictly inferior than 2k. Okay? Let's flip this inequality. I get here 2k is bigger than 7. Okay? So which condition make 2k bigger than 7? We must give k must be superior to 4. Okay? This one holds, which means this side is inferior than this side if k is bigger or equal to number 4. This one if k superior to number 4. Okay? We get a perfect square, which is between two consecutive squares on this interval if we have k is superior to 4. But the problem, what about k equals 1, 2, 3? Okay? So we need to check these obvious cases, k equals 1, 2, and 3 manually in order to decide this one. It's impossible to be on this interval. Okay? This is not complete job. We need to check this obvious case of k, which is 1, 2, and 3, then decide this one. It will be impossible for the entire thing. Okay? Let's check if k equals 1, 2, and 3. Okay? If k equals 1, I get, since we have y equals 1 plus k, I get y equals 2. Okay? So which means if k equals 2, which means y equals 3. If k equals 3, which means y equals 4. Replace this value. Let's take this value of y and insert it back into this equation to see it's giving us a perfect square or no. Okay? So for this one, I get square, which is a perfect square, equals 2 square, which is 4, 4 plus 4, which is 8, 8 plus 13, which is 21. 21 is not a perfect square. Okay, let's check y3. 3 square, which is 9. I get here 3 is multiplied by 2, which is 6. 6 plus 9, which is 15. 15 plus 13, which is 28. 28 is not a perfect square. Okay, let's check the last case. If y equals 4, y equals 4, I get here 16. I get here 8. 8 plus 13, which is 21. 21 plus 16. 21 plus 16, which is 37. 37 is not a perfect square. If you take this condition, this one, and this inequality on this interval, okay, together will be gained the contradiction, okay, which means y is strictly superior than 1. It's impossible. Okay, this one is telling us y must be is inferior or equal to 1. Okay, this one. But this is one side. Let's check the other side of inequality. Okay, case number 2. Okay, by the way of contradiction, suppose y is strictly inferior than -3. Okay, for the negative integers, which y is strictly inferior than -3, we are going to work on this one to check where we have a contradiction. Okay, so for this one, let's set y equals -3 plus k. So which means as you go in below this number -3, you get more negative numbers coming up. Okay, so always k is superior to 1 as a natural number. Okay, so I'm going to do the same thing, just replacing this one into the original equation. I get here the following. I get x squared, which equals y squared, which is 3 plus k quadrant square. This minus sign is going to be cancelled out with this square. So plus 2 times with this minus sign that I have, I'm putting this minus in the front. I get 3 plus k, replacing y with 3 plus k, plus number 13. Okay, let's simplify this one out. I get here k squared. I get here 6k with minus 2k. I get here plus 4k. I get here 9. I get minus 6, which is 3, plus 13, which is 16. Okay, this expression that we find now, it's the same expression that we found before. So this one exactly strictly inferior than k plus number 3 square, strictly superior than k plus number 2. Okay, so always this one k is superior equal to 4 as we found before. Okay, so we found the same thing here. Check the values that I found before. K equals 1 and 2 and 3. Okay, also is giving us a contradiction. It's impossible. Okay, plus this inequality that we have here, which is impossible to have a perfect square, is located between two consecutive squares on this interval. Okay, including this condition. This condition doesn't work as well, because which means it's impossible to get the solution on this interval, which means above this interval, that's the solution of this one. -3 is inferior to y. We already found y is inferior to 1. Okay, so this is the solution must be on this interval, which means y must be in this set: -3, -2, -1, 0, and 1. Okay, but after you checking this value, after you replace this value of y into the original equation, you will see 0 doesn't work, minus number 1 doesn't work, -2 doesn't work. Which works? -3 and number 1. Okay, so thus you get y equals 1 and y equals minus 3 are only the solution for this equation, which they are here, which belongs to this previous solution that I found. So I get minus 3, which is this one. I get 1 is this one. Both solutions are corresponding to x, okay? So which is this one. So I have ended this video. Don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.